Hello everyone, you are welcome to our school YouTube channel, and today we'll be continuing with the organic chemistry series. The topic we have to talk about today is functional group and general formula. Ways for you to remember the functional group and general formula of the homologous series we talked about in our previous video. So if you have not watched the previous video, please go back and watch the previous video, alright? So stay with me and learn. This is all we'll be talking about today. All of these homologous series. We want to know the general formula and then know the functional group, okay? But how can we remember all of these without cramming? That is why I am here today. So stay with me and learn. Okay, look at all of this. Now, the first three things we'll be looking at here is alkane, alkene, and alkyne. These are the first three things we'll be looking at here. How can we remember this? How can we remember this? Now, alkane is the first here, alkene is the second, and alkyne is the third. Looking at this now, we have alkene. Alkene. Let's take alkene to be our reference point. And the general formula for alkene, know it, okay? General formula for alkene is CnH2n. So if we go above alkene, we will have alkane, right? If we go below alkene, we will have alkyne. Exactly. Now, going above alkene now is going to be an addition to our reference point. And what are we adding to? We are adding to the hydrogen atom of our reference point. You get? So when we are going below alkene, we are removing from the hydrogen atom of our reference point. How do I mean? Look at it this way. This is alkane. Alkane. Remember, our reference point is CnH2n. Alkane now is CnH2n plus 2. 2 is adding to the hydrogen atom of our reference point. Exactly. Now, and then 2 is removing from the hydrogen atom of our reference point for alkyne. Exactly. So when I'm going above alkane, when I'm going above, 2 is adding. When I'm going below, 2 is removing. From what? The hydrogen atom. Now, there's a group we must know if we want to talk about the general formula of homologous series. That group is all called the alkyl group. The alkyl group. But how is this alkyl group formed? How is this alkyl group formed? We already talked about how these three are formed, right? Now, how is this alkyl group formed? Take alkane. This alkane, A-N-E. Take alkane. When this alkane loses one hydrogen, remember, this is the general formula for alkane, right? When this alkane loses one hydrogen, it will form an alkyl group. Exactly. It will form an alkyl group. Now look at it. CnH2n plus 2 minus 1 hydrogen. It will form an alkyl group. Remember, what we are minusing from is still the hydrogen, right? So we'll have CnH2n plus 1. Knowing this is the framework for knowing the general formula of the homologous series. Exactly. Right. Now, questions. The alkyl group is represented by the general formula. What? Okay. Pause the video and attempt the question. Yes. So what is the answer? Of course, you know that D cannot be the answer because D is the general formula for alkene. Okay. And then when 2 is added to the hydrogen atom of alkene, it will form alkane, which is our option A. Alright. So if 2 was to remove from the hydrogen atom of alkene, we will form what? Alkyne. But right now, we don't have alkyne. But what we're asked in this question is alkyl group, right? So when one hydrogen atom leaves the general formula of the alkane, we are going to form the alkyl group. Do you get? So our answer here is option C. The alkyl group, the general formula for the alkyl group is CnH2n plus 1. Exactly. Alright. It's time for us to know the functional group of this homologous series. Now, haloalkane, the functional group of haloalkane is represented as S. What is S? S is halogens. Halogens, for example, fluorine, chlorine, bromine, and iodine. These are halogens. Okay. Now, another of what we have to know is the arcanol. Arcanol. The functional group for arcanol is OH. Okay. And then there are two confusing stuffs that you must know. It's very confusing, but with this, you should be able to know it. It is the arcanone and the arcanal. Arcanone and the arcanal. The functional group for arcanone is different from the functional group for arcanal. Please take note that another name for the arcanone is the ketone, while another name for the arcanal is the aldehyde. But how should we know the functional group without getting it mixed up? Remember I said, another name for the arcanal is the aldehyde, right? Another name for arcanal is the aldehyde. Aldehyde. The H for aldehyde, they hide. Okay? They hide. The H, they hide. And the H here, look at the functional group, aldehyde. The H is hiding in between C and O. But for arcanone, you don't have the H hiding in between the C and O. As a matter of fact, for arcanone, there is no H in between C and O. That's why we pronounce it as arcanone. Arcanone, C-O. Exactly. And then we have the arcanoic acid. We have the arcanoic acid, and arcanoic acid is COOH. Exactly. So let's go over it again. We said haloalkanes, the functional group for haloalkane is S, which is what? The bromine, the fluorine, the iodine, right? And then we said arcanol is what? OH. We said arcanone is CO because it is arcanone, CO. And then we say arcanal, aldehyde. The hydrogen of the aldehyde is hiding in between the C and the O. And then we say arcanoic acid is what? COOH. Exactly. All right. Now, question. The general formula for the arcanals is what? Arcanal. Remember, another name for arcanal is what? Aldehyde. So, pause this video and answer this question. Okay. Another name for the arcanal is aldehyde. So, what is the answer to this question? Aldehyde means that what? The hydrogen of the aldehyde, they hide in between what? C and O. So the answer to this question is what? B. Option B is the answer. Alright. Now another question. An example of an alcohol is what? Okay, I want you to pause this video and attempt this question. Okay. Now, why do you think B cannot be the answer? B cannot be the answer here because B is not alcohol. It is arcanoic acid. Alright. Now, I want you to know that another name for alcohol is arcanol. B is arcanoic acid and it cannot be the answer. Okay, arcanol, the functional group for arcanol is OH. So the correct option here is option E. Why? Because option E has OH in it. So option E is an example of alcohol. Exactly. All right. Okay, now the functional group for alkoxyalkane is O, and the functional group for alkanoate is COO. Now the reason this alkyl group, the general formula for this alkyl group has been blinking is because you have to know this alkyl group to know the general formula of all of these. Okay, and how do you know the general formula for all of these compounds? This is very easy. Now that you know the general formula for an alkyl group, just add the functional group to it. You have that of that homologous series. Do you get what I'm saying? This is what I mean. For haloalkane, the general formula for an haloalkane is CnH2n plus 1x. That is, take the alkyl group and add the functional group of that homologous series to it. Exactly. So what do you think will be the functional group for alkanol? It will be what? Alkyl group plus OH. What do you think will be the functional group for the alkanone? It will be what? The alkyl group plus CO. And the alkanal or the aldehyde will be what? The alkyl group plus CHO. And then alkanoic acid is this. And then alkoxyalkane is this. Okay, now look at alkoxy-alkene. If you check the functional group of the alkoxy-alkene, I put dash on the left-hand side and dash on the right-hand side, meaning that an alkyl group will add to the left-hand side, another alkyl group or the same alkyl group will add to the right-hand side. That is why it's like this. So alkyl group on the left, alkyl group on the right. So what do you think will be the general formula for alkanoate? Remember, we still have dash here and dash here, right? So the alkyl group will be added to the left side of COO, and alkyl group will be added to the right side of the COO also. Exactly. This is it. All right. Amine and amide can also be confusing. The general formula and the functional group can also be confusing. But how can we know this without cramming? How can we know them without cramming? Okay. Amine, amide. Amine and amide. Okay. So look at it. Both of them were tending to be ammonia, but the amine looks more like ammonia. The amine sounds more like ammonia than the amide. That is why you have NH2 in both. But the one that looks like ammonia, that looks almost like ammonia is the amine, while the amide is CONH2. Exactly. So with this, it will not be confusing again, right? All right. Now, how do we know the general formula for all of this? It's very easy. We've said that before, that the alkyl group plus the functional group is equal to the general formula, right? Now, look at it. What's the functional group for the amine? It is CnH2n plus 1 NH2. And then the amide will be what? CnH2n plus 1 CONH2. Exactly. Now, another question, okay? The two functional groups in the above compound are. So pause this video and attempt this question. So we have the alcohol and amine, acid and amide, aldehyde and acid, ketone and amine. Okay? But how are you going to know this answer? Check this compound. If you check the left-hand side and you check the right-hand side, you have one group on the left-hand side and another group on the right-hand side. What is the group on this right-hand side? And what is this group on this left-hand side? Check the left-hand side. The left-hand side, this is it. H2N. That is the same thing as NH2, which is the functional group for what? And amine. It is not amide. It is what? Amine. This is the functional group for the amine homologous series. Are you getting me? And then when we come to the right-hand side, we have the COOH. The COOH, not just the CO, but COOH. This is the functional group for the arachidonic acid. I know you are surprised that you are not seeing arachidonic acid, but you are seeing acid, right? Arachidonic acid is an acid. That is why we call it arachidonic acid. It is an acid. So the functional group for the acid is COOH. So the functional group for the amine is NH2. So our answer here is option B. Exactly. Thank you very much for watching this video. Remember, this is just a part of our organic chemistry series. More videos are going to be released. So remember to like this video, subscribe, hit the notification bell and share. Thank you very much.